Hello, here in this video I'm going to be going through the final exam review. Let's go ahead and start, noting that I'm going to be telling you what chapters things are from. Now some of them might be from a slightly different chapter, but the knowledge was needed and was maybe retaught in that particular chapter. This says classify it by its degree and number of terms. So the degree is the highest exponent. So this is a fourth degree. And then there's two terms, so it's called a binomial. That's a fourth degree binomial. How many solutions does this quadratic have? If any, find them using any method. So this is a quadratic situation, and I know that because the highest exponent's 2. That means we could try to factor it. We could try to use the quadratic formula, and there's other methods as well, but they're not going to be as good of a choice here because of the a value. So anytime you're looking at a quadratic and you're trying to find the solutions and you don't want to attempt factoring, what you'll want to do is jump into the quadratic formula. And that is negative b plus or minus the square root b squared minus 4ac all over 2a. We're on this one. Our b was 5, our a was 3, and our c was a negative 10. So then we'll have a negative 5 plus or minus 25 plus 120, all divided by 6. So we'll have negative 5 plus or minus the square root of 145 all over 6. Now, you can attempt to simplify the square root of 145, but there's no perfect squares within it. So that's our final answer. So this one had 2 solutions. And those 2 solutions are negative 5 plus the square root and negative 5 minus the square root. Because that plus minus is what gives us the 2 solutions. This one asks, what's the best method to solve? The best method to solve this one is going to be the square root method because there's no regular x's. And when there's no regular x's, you're free to solve like a regular old Algebra 1 equation, to where we divide both sides, square root both sides, and we'll get that x is equal to plus or minus 4. This one asks, what is the b term in this quadratic? The b term is always the term with the x, so in this case, b is equal to 2. So this is getting back into chapter 5. We needed it in chapter 6 as well. What is the slope? Well, remember when we're working with y equals mx plus b, that slope is the m value, or the number that's with x. So in this case, our slope is equal to this positive 4. This is asking us to simplify using rules of exponents. Remember that anything to the 0 power is equal to 1. So this is equal to 1 over 7. This one, we'll identify the slope as the number that's with x. The y-intercept is always 0, comma, and then the number on the end. So this one has a slope of 0 because there is a 0x right there. And then it's a plus 3, so the y-intercept is 0, comma 3. Write an equation using any form of a line with the given information. So they've given us a slope, so I'm going to put y equals 2x. They gave me a y-intercept of 6, so it'll be right there. The slopes of perpendicular lines, now remember that perpendicular lines are lines that form that 90-degree angle, are opposite reciprocal. So an example of that is if one of the slopes is 2/3, the other one must be negative for the opposite, and the reciprocal, so negative 3 over 2. So there is an example of slopes. Now, y-intercepts don't impact if two lines are perpendicular. So let's do y is equal to 4/5 x minus 2. If this line was going to be perpendicular, it must have a negative 5/4 slope, but then the y-intercept can be whatever you want. Right, you could do plus or minus anything. I'll just pick 7. The slopes of parallel lines are identical. Now, in order for two lines to be parallel, they must have the identical slope, but they must also have a different y-intercept, because if they have the same slope and the same y-intercept, those two lines will be stacked on top of each other. So let's do y is equal to negative 3x plus 4. That means this other equation must also be negative 3x, and then plus or minus anything that's not a positive 4. So I'll just do a minus 5 for mine. So we're going to solve each system of equations graphically. And when we're solving systems of equations, what that's asking us to do is find out where do these two lines cross over on a grid. And that crossover spot is the solution. So we're going to graph these using y equals mx plus b. So I'll do this first one here in blue. It has a y-intercept of 5. There's the y-intercept of 5, and its slope is up 3 to the right 1. You see that takes us off the page, so you can also do the opposite of both, which will be down 3 to the left 1. So I'm going to do down 3 to the left 1 as many times as I can, and that will give me my line. Now for the second one, which I'll do in green, I need to subtract 2x from both sides first, so that I have it in y equals mx plus b form. Now it has a y-intercept of negative 5. So here's negative 5, and its slope is negative 2/1. So down 2 to the right 1. That'll take us off the page, so we can do the opposite of both, which is up 2 to the left 1. And if I go up 2 to the left 1, you'll see that these lines do in fact cross right here at this point. So this solution is negative 2, comma, negative 1. Let's graph these equations and see where they cross over. I'll do this top one in blue. Y-intercept of 1, slope is down 1 to the right 2. We can do the opposite of both as well. For this one, it also starts at a y-intercept of 1, so we can see our crossover spot right there, and its slope is up 1 to the right 3. So those lines cross right there on the y-intercept, which you might have been able to see right away. And that's 0, comma 1. So continuing on with systems of equations, now we're going to use substitution. And substitution is where you take what something is equal to. In this case, y is x plus 7. So I can replace this y with an x plus 7. And then have it be equal to 2x minus 8. And now, once I go through and solve this equation, what we'll get that 15 is equal to x. Now, that tells me the x-coordinate of my answer, but to finish finding the y-coordinate, we're going to need to go back to one of the equations and plug in the 15. And we'll get that y is equal to 22. Now, another thing that you'll want to do is you'll then want to use whichever equation that you didn't use to go back and double check that the solution is correct. So when I do that, here I get 30 minus 8, and it does give me a 22. So that confirms that this solution is correct. So in this one here, x is equal to y plus 2. So I can replace that x right there with a y plus 2. And then we can go through and solve. So here we'll have 3y plus 6 minus 4y is negative 5. These are on the same side of the equation, so they're like terms. So as we're going through and solving, you get the negative y is equal to negative 11, so y is equal to positive 11. We'll find the x-coordinate by going back into one of the equations and plugging in y as 11. And when we do that, we'll get that x is equal to 13. And you should always double check it with the other equation to make sure that we didn't make any small mistakes. And when I plug in 13 and 11, we get 39 minus 44, which does give us a negative 5, confirming that answer is correct. Elimination is where you're going to go through and add up the two equations. So in this case, we'll get x plus x is 2x, positive y plus negative y is 0 is equal to 6, and we'll get that x is equal to 3. And then you can go back into either equation to figure out what your other variable is. So when I subtract 3 from both sides, here we'll get that y is equal to a negative 1. We can go back into either one of those equations and plug in y as negative 1 to figure out what our x is. And on this one, when I add 1 to both sides, I get that x is equal to 3. And you can double check these as well. If you double check the solution on the second equation, you'll see that it is in fact correct. Now, sometimes on elimination, when you try to add right away, nothing cancels. Those don't cancel and those don't cancel. So what you'll want to do is manipulate one of the equations so that something does cancel. I'm going to focus on canceling out my x's. So if I need this x to cancel out with a 2x, I need it to become a negative 2x. So I'm going to multiply this whole bottom equation by a negative 2. So we'll get a negative 2x plus a 2y is equal to a positive 2. Because I took that entire bottom equation and multiplied all of it to keep it balanced by a negative 2. And then when I box those two, when I go to add them up, the x's are going to cancel out. And we'll get a negative 2y is equal to a negative 4, getting us that y is equal to a positive 2. And then from there, I could go back and plug it into the second equation to figure out what x is. When I add 2 onto both sides, I'll get that x is equal to 1. And as always, you can go through and double check it and make sure that it works. If I plug in 1 for x and 2 for y, we'll get 2 minus 8 is equal to negative 6. 2 minus 8 is negative 6. So that gives us confidence that our answer is correct. This says the sum of two numbers is 22 and their difference is 14. What are the two numbers? This is actually a systems of equations, and you could figure it out with guess and check, but systems of equations allow us to go right to the answer. So the sum of two numbers, I don't know what they are, so x plus y is 22. And their difference, which would be x minus y, is 14. It wants to know what the two numbers are. So this could be a good elimination scenario, to where I'm just going to stack these equations together and then add them up. So we'll get 2x is equal to 36. So x is equal to 18. And if x is equal to 18, that means that y must be 4. And you could try that on both of those. 18 plus 4 is 22. 18 minus 4 is 14. Here's another scenario where we have to use systems of equations. You're getting ready to move and have asked some friends to help. For lunch, you buy the following sandwiches at the deli for $30. 6 tuna sandwiches and 6 turkey sandwiches. So I'm going to let's let x equal number of tuna sandwiches and y equal number of turkey sandwiches. So for $30, we bought 6 tuna sandwiches and 6 turkey sandwiches. We can see all that right there. Later that night, everyone is hungry again, so this time we buy 4 tuna sandwiches and 8 turkey sandwiches, and this time it cost us $30.60. So we want to know what was the price of each individual sandwich. Maybe now people want to pay you back and you didn't keep the receipts to see how much each sandwich is worth. You could use systems of equations to figure out how much each one is worth. Now, we could use elimination, but this one would be a little more difficult to do that. So what I'm going to do is I'm going to go to this top equation, and I'm going to divide everybody by 6. And what that's going to allow me to do is get this equation, that 5 is equal to x plus y. Then I'm going to go ahead and subtract a y from each side, or an x, either one. I'm going to choose y though. And now I know that x is equal to 5 minus y. So if I come down to this second equation, I can now substitute x as 5 minus y. So then we'll have 20 minus 4y plus 8y. I'll go ahead and subtract the 20 from both sides and combine my like terms. And when we do that, we get that 4 turkey sandwiches cost $10.60. So if we divide both sides by 4, we'll get that y, so turkey sandwiches, cost $2.65. Now to figure out how much the tuna sandwiches cost, we need to go back to one of the equations and substitute in $2.65 for y. And when we do that, we get $15.90. And we could subtract the $15.90 from both sides and get that 6x is equal to $14.10. And when we divide by 6, we get the tuna sandwiches are $2.35. Here's another systems of equations. I'm going to let boxes of pencils represent x, boxes of pins to represent y. So we bought 3 pencils and 1 box of pins for $9. And then we bought 1 box of pencils and 2 boxes of pins for $8. And we're going to find the cost for both. I'm going to use elimination on this one. I'm going to take this top equation and I'm going to multiply it by -2. And you'll see that when I do that, I get my y's to match up very nice. Because right here, these y's are now opposites. So we'll get -5x, the y's cancel out. It's -10. So x is equal to $2. It's $2 for a box of pencils. Can plug that into either one of my original equations. I'm going to choose the second one. And when I subtract it, we'll get that y is equal to 3. And that pins are $3 per box. So here we're asked to simplify some square roots. So recall that that means we want to set it up to where we are expressing the inside number with multiplication, where one of the numbers is a square root. The square root of 25 is 5, and then the square root of 2 stays. For the 20, that would be 4 times 5. Could square root the 4 to get a 2, and then 2 square root of 5 would be our answer. Here we have a relief organization flew over a village and dropped a package of food and medicine. The plane is flying at 1,000 feet. The function h is equal to -16t squared plus 1,000 gives the package's height h above the ground after t seconds. Graph the function. How many seconds does it take the package to hit the ground? Alright, so here's what we have. We're going to be making a table with time values and height values. We know that when they first drop it, so at time 0, it is 1,000 meters up in the air, or feet rather, 1,000 feet up in the air. So when we drop it and time starts to increase, we can find these different values by plugging them into this equation, because our height is equal to time squared plus 1,000. And if you plug each of these values into that scenario, here's what you would get. So you can see as you're filling out your table here, and you can find these by plugging in each of these values, you can see that it's still got plenty of room to keep falling. So if you kind of skip some here, when we get down to 7, it's at 216 feet, but then at 8, it's at negative 24, which means somewhere in between here is where it hits the ground. So how many seconds does it take to hit the ground? The answer to that is between 7 and 8 seconds. And we could use quadratic formula to find that exactly, but here's what this graph would look like. We know that at times 0 is at 1,000, so if here's times 5, then here's times 10, in between 7 and 8, we're hitting the ground. And we know that it would look something like this because at first it's not changing very much, but then it starts to change a little more rapidly at the end. So here we're going to be solving by the method that they instruct us with. For 49, they want us to use the quadratic formula. So we'd have negative b plus or minus the square root b squared minus 4ac all over 2a. My b value is negative 2. So we'd end up getting positive 2 plus or minus the square root of 4 plus 48 all over 6. So we have 2 plus or minus the square root of 52 all over 6. And those are going to be our two solutions, because there's no further way to simplify the square root of 52, as there's no more perfect squares within it. This one asks for us to use completing the square. And that's where we could use quadratic formula, but completing the square is a faster process. The first step of completing the square is to get your c term to the other side. So I added 6 to both sides. And then we have to think about, well, what would this look like to split it up into 2 equal pieces? If we were going to split up into 2 equal pieces, the 4 would split to 2 and 2. And to find that c term, you have to multiply the 2 and 2. So I'll need to add that 4 onto both sides. But that allows me to get x plus 2 squared is equal to 10. And then we can square root both sides to get that x plus 2 is equal to plus or minus the square root of 10. So once we subtract the 2, we get that x is equal to negative 2 plus or minus the square root of 10. Here we're asked to simplify the expression. So for the 20, we have 4 times 5. We can square root the 20. We can square root the 4 to be a 2. Now for the x to the 5th power, what we're going to do is split it up into x to the 4th and then x. Because remember, with square roots, we divide the exponents to get them to come out. We divide it by 2. So if I have x squared, that means I can get 2 groups of x out, but left over is the 5 and the x. For this one, first off, we could view as 60 divided by 15 as simply a 4. And then we use rules of exponents. That'd be top exponent minus bottom exponent to get 4x to the 5th. We can square root the 4. We can split x to the 5th into x to the 4th and x, getting us 2 groups of x squared. Square root of 4 is 2. When I take this exponent of 4 and divide it by 2, we get x squared with the square root of x left over. So we're going to graph the following quadratics using 3 points, state the axis of symmetry, vertex, and domain and range. So recall that axis of symmetry is x is equal to negative b divided by 2a. So we have negative b divided by 2a. So what we're going to have here for our axis of symmetry is an 8 over 4 to get that x is equal to 2. And recall that the axis of symmetry is the dotted line that passes through the vertex, the x-coordinate of the vertex, which makes the x-coordinate of our vertex 2. So then to find the y-coordinate for our vertex, what we're going to need to do is go back to the original equation, and everywhere there's an x, we're going to plug in the 2. So here we get 2 squared to get 4. 4 times 2 is 8. So we'll get a negative 8 plus 1 to get that our y is equal to a negative 7. Y-intercepts are always 0, comma c. So here we have 0, comma 1. And so it's said to just use 3 points, and we'll actually have enough here because my vertex is at 2, negative 7, which would be just barely off the graph here. Our y-intercept is at 0, comma 1. The axis of symmetry would look like this. It's the dotted line that travels through the middle of it, which means from a reflection standpoint, there must be another coordinate point right there. So there is our 3 points. Now, remember that domain talks about all the possible x values. This graph would eventually branch to the left and branch to the right as far as 1 and 2. So that makes the domain all real numbers. Range, though, is different. Notice how this graph has a lowest point. And that lowest point is here at negative 7. So range is talking about y values. So we'll say, hey, our y values are always greater than or equal to negative 7. Because you can be equal to negative 7, but otherwise you're always higher up than that negative 7 value. I realized here now we had skipped a few pages, so sorry that this is going to be bouncing around. But let's go ahead and finish off while we're here with the quadratics. So we're going to do the same process. Axis of symmetry is negative b divided by 2a. But notice that this time our b is equal to 0. So when I go to replace a here with an invisible 1, we get x is equal to 0 divided by 2, which gives us a value of 0. Which means the x-coordinate for our vertex is also 0. Now to find the y-coordinate, we have to go in, and everywhere there is an x, we have to plug in a 0. And we'll get that y is equal to 2. Now, y-intercept, which is 0, comma c, is also 0, comma 2. And that can happen sometimes where the vertex is the y-intercept. That'll happen anytime that your b value is 0. So what that means to find other points is that we'll need to make a table. To make a table, you put your vertex right in the middle, and then you count down the x column and up on the x column. Now this graph only wanted 2 points, so I'm only going to have to plug in one of these because of the symmetry. So I'm going to go back to my original equation, and I'm going to plug in either 1 or negative 1. I'll pick positive 1. And when we do that, we'll get that y is equal to 3. And because of the symmetry, those points will be the same on both sides of the quadratic. It'll look like this, and then up it goes. For the domain, it's all real numbers. For the range, we have to look at this and talk about all the possible y values. And so that's going to be where y is greater than or equal to 2. We are always 2 or greater on this graph. So let's go back now, sorry about this being out of order, to these right here. So we're going to be graphing linear inequalities here. Now, inequalities are where instead of the equal sign, you have the inequality signs. Now, this one here is also an absolute value. And the way that we did absolute values was we know that they were a V shape. And that V shape traditionally started at 0, 0 with a slope of 1 and -1 to make that V shape. But what we learned is that this number impacts the x location of the vertex of the V, and then it was actually the opposite of what you'd expect. So we're now going to start our V at 2, comma, and then this number on the outside impacted our y coordinate. So this V is actually going to start at 2, 5. So it'll go up 1 and over 1 in both directions. But since there's no line under my inequality, it's going to be a dotted line. So this V shape would look like this. Now, inequalities have a shade. And since this is y is less than, I need to shade all of the y values that are below. So the picture to this graph would be, even if we extended it out, would be everything on the outside of this V. Systems of inequalities is where we graph two inequalities and see where did the two shadings overlap. So I'll graph this first one here in blue. It's down 2 on the y-axis, slope of -1. So I'll plot a couple points here. I'll go ahead and just put all the points to help me draw the line. And I'm going to leave myself a note here that I'll be shading this one below. Now for this one, it has a y-intercept of 1 and a slope of up 1 over 3. There's no line under its inequality, so it's going to be dotted. And I'm going to be shading this one above because it's y is greater than. So I'll go ahead and do that one first. I need to shade everything above my green line, which would be those two sections there. And then I need to shade everything below my blue line. And then you can see that the two sections overlap right here in the red. That overlap is your answer. If you pick any coordinate point from that red shaded area, it's going to work for both of those equations. Now here we'll be doing rules of exponents. The way that these work is regular numbers, so our constants, so in this case 7 to -3, they multiply like normal. But then the rule for variables was same base, add the exponents. Here, 21 divided by 3 is 7. The rules for division was top exponent minus bottom exponent. So 3 minus 1, invisible 1, is 2. But for the y's, top minus bottom would give me a y to the -6, which means it needs to go on the bottom of the fraction as the reciprocal, like that. Here we have same base, add the exponents. So for the x, I have 3 plus 1 is 4, minus 2 is 2. And then here, we're doing the y's. -1 plus 1 is 0, plus 2 is 2. This is the power rule, where if you have an exponent to an exponent, you multiply. And then it's same base, add. And since that's a negative exponent, we'll need to take the reciprocal and get the g to the 37th power in that denominator. Here, 21 divided by 3 is 7. And then we'll do top exponent minus bottom exponent. And we'll get 2/4, which I could simplify back down to m to the 1/2 power. This one's reminding us that anything to the 1/2 power is actually just a square root. So this is all to the square root. So we'll need to simplify the 72, which would be 36 times 2, where 36 is a perfect square for 6. So this will be 6 square root of the 2 and b left over. So this is where they give us specific values for the variables. So we'll go ahead and replace them. Tells us that x is -3 and that z is 5. So 3 to the -3rd is 27. So here we have 6 times 27. Anything to the 0 power is 1. So this ends up just being 6 times 27 to get 162. Now, for this one, before I substitute in any of my variables, I want to make sure that I go ahead and take care of the fact that this p to the 3rd power really needs to be in the denominator. And now I can substitute my variables. X is -3, z is 5, and the p as 2. And now we can go through and evaluate. So -3 to the 4th power will become positive. It's a positive 81. 5 to the 3rd is 125, all divided here by 8. So if we go through and take care of that, what we get is some large numbers. And if we divide those, though, we get 1,265.625. So here we're going to simplify and write each answer in standard form. Standard form is where you put the highest exponent out front. We also need to recognize that we've got some subtraction, so we're going to need to distribute. And when we do that, what we'll then have are two groups of 3 that we can put together. Sorry, I left off my squared here. So 6j squared minus 3j squared gives me 3j squared. Minus 2j minus 4j gives me minus 6j. And then plus 5 plus 6 will give us plus 11. Now notice that that answer is already in standard form because I have my highest exponent first. Here we have another subtraction problem, so we must remember to distribute that. And then we'll combine like terms. So here we have some h to the 4ths. So we'll have negative 6h to the 4th. Now we have an h, but we have minus h squared. And so in order for this to be in standard form, I need to do this one first. So we have minus 3h squared. Then I can bring in the h with the 4h to get plus 5h. So we're going to continue to simplify each product and write it in standard form. And so what that'll look like is multiplication. So we'd have 2y cubed minus 3y squared plus 6y. Now remember, when something's squared, you do have to write it out twice and then do FOIL to get x squared plus 3x plus 3x plus 9. So the final answer for this one is x squared plus 6x plus 9. People who rush through it will just say x squared plus 9 like that, which is incorrect, because when something's squared, it's telling you to multiply it out twice. So here with FOIL, we'll get 2x squared plus 4x minus 3x minus 6. And when we combine like terms, we get our simplified answer there. Here, we're just going to continue to distribute to everybody. So we'll get 2x cubed minus 10x squared plus 6x. And then we'll get a plus 3x squared minus 15x plus 9. And when I combine like terms, we'll get 2x cubed minus 7x squared minus 9x plus 9. So here it tells us to factor each expression. So the easy type of factoring is when we have the 1 out front, because all we're looking for are numbers that multiply to the c term that add to the middle. So here, in this case, it would be a minus 7 and a minus 5, because those numbers multiply together to give me a positive 35 and add together to give me a negative 12. Now, anytime that your leading value is not a 1, you first want to check for a greatest common factor. All of these are divisible by a 2. And when we do that, we'll be left over with this. And it's still the more difficult type of factoring, because this one's going to have to start off 3r and r to get r squared. So now this middle term of negative 5 isn't going to come from these two numbers simply being added up, but instead the o and I of FOIL. But I'm still looking for numbers that multiply together to give me a negative 12, which would be 1 and 12, 2 and 6, and 3 and 4, where 1 is positive and 1 is negative. And if you try enough of the combinations, eventually you'll see that we need to do this. Because when I FOIL those out, I'll get a negative 9r plus a 4r, and those together combine together to give me the negative 5r. The other method that we saw of doing that was this. If we had 3r squared minus 5r minus 12, we multiplied these outside terms to get 36, or negative 36, and then we could go back to finding numbers that multiply together to give me 36 that add to a negative 5, and those would be a negative 9 and a positive 4, and then we could do it with factoring by grouping, to where we look at the first two. We could bring out a 3r to get an r minus 3. And then when we looked at the second two, we could bring out a positive 4. And then the GCFs form a group. And the term that shows up twice forms a group, which you'll see that this factorization is the same thing as that. We just have to remember to put that GCF of 2 back out front as well. For this one, we have a GCF of 2 for the numbers and a C for the variables to give us C plus 2. And that's as far as that one will factor. The two-term ones in this form are a little bit easier. This one's two terms as well, but it's the B value we're missing. There's no greatest common factor, but when there are two terms and they are minus, we knew it had to be plus and minus. What you then look to do is square root those two terms. So it would be an 8n and an 8n, and then a plus 1 and a minus 1. And if you don't believe that, FOIL it out. The 8n times 8n is 64n squared. I get a minus 8n, a plus 8n, and a minus 1. Those would cancel out, giving us the original answer. So here we're going to solve each equation using the method stated. For this one, square roots. And that's where you solve it most traditionally. you get the x squared by itself and then square root. We'll get plus or minus 5. Solving by factoring is where you first factor. So I need numbers that add or multiply to -6, but add to a positive 1. And then you take both pieces and set them up equal with the zero product property. And then you get your two solutions that way. This has been the Algebra 1 semester review. You can watch it again. Be sure to ask more questions if you need more specifics. I went fairly quickly through this because otherwise it would take many, many hours. And a review isn't a reteaching tool. It's supposed to help you to shake off the dust. But if you need to be retaught, reach out and we'll sort it out.